All right, so like I said, we are going to just keep looking at this unit circle over and over again in different ways. So we're just going to hit on reference angles again to show you how important they are. So if you truly understand a unit circle, then all you really need to know is the first quadrant. We went over that, how that if you just know whatever the points are of a certain angle, say it's AB, then you flip it over the y-axis, we know that the x changes. We flip it over the origin, we know they both change. And if you flip it over the x-axis, then just the y value changes. So we're going to work with that concept, but with unit circles. All right, so for example, say we take the sine of 230. That means we opened all around and we stopped at that dot right there, 230. It won't stop at 230. There we go. What we want to look at is this reference angle in here. And remember, the reference angle is the angle distance to the x-axis. So 230, the x-axis at that point is 180 degrees, so that is a reference angle of 50. So now, you don't have 50 as one of your special angles in your unit circle. So if you take out your calculator, the first thing we're going to do is go into our mode and make sure that we're in degree, and we are. Now if I take the sine of 50, see the answer I get? It's an irrational number. If I take the sine of 230, I get the same answer, but it's negative. And that's right, because remember we said if we started over here with a point in the first quadrant, when we flip it over the origin, which is what this angle did indeed do, both the cosine and the sine are going to be negative. Now you may be thinking, I think that was the answer. You may be thinking, well, why would I even do that? I can just take out the calculator and press the buttons and get the answer. I know. We're just drilling this into you to make sure you understand how to get these angles. So for example, let's go on now. The cosine of 410. So I'm going to come back here. I'm going to go 410 degrees, which means I'm going 360 degrees. And look at that. 50 degrees more. So this too has a reference angle of 50. So if we knew what the cosine of 50 degrees is, it is 64.28, let's say. Then the cosine of 410, well, that brought me into the first quadrant, so that means everybody is positive, so that too is 64.28. And so just so we understand reference angles, sine of 176, okay, so 176 is going to be right there. And boom, whoops, 177, you get to see. And 176, its reference angle is, I'm that short of 180, so it's 180 minus 176, so its reference angle is 4. And then 284, if I wanted to figure out its reference angle, I'm going to go all the way around. There's 270, and then 284 is right here, and this is where the problem starts. Remember, the reference angle is to the x-axis. So how far of an angle measure do I have to get to the x-axis? Well, the x-axis is 360. I'm sitting here at 284. If I just subtract those two, I get 76. So its reference angle is 76. So how about if we were to work in radian measure? Okay, this is where it gets a little more complicated. So let's move this over so we can see it. First off, I'm going to represent this as 2 pi and this as pi. Now the reason why I am not labeling pi over 2 and 3 pi over 2 is because a reference angle only refers back to the x-axis. And this is also 0, but we don't really use 0 when we're trying to find a reference angle. So the first thing I'm going to do is I'm going to look at 3 pi over 5 as 3/5 of pi. So 3/5 of pi means, well, I'm beyond half pi, because 3/5 is bigger than 1/2. I'm somewhere over here. So the distance to the x-axis is that angle measured right there. Well, all I have to think is the x-axis in that case is pi. Take away 3/5 pi means the reference angle in pi would be 2/5 pi. Because this is 5 over 5, because it's 1. Get it? All right, so let's go back here. The next one says to move 4/3 pi. So that means I'm going 4/3 of pi. Well, that means I'm going more than pi. I'm going 3/3 of pi and a third more. Well, how does a third relate to 1/2? It's less than, so I'm somewhere in here. So once again, I have to find this angle. How far away from pi am I? Well, this time I went beyond pi, so I'm 4/3 pi, take away pi, which means I'm 1/3 of pi. Seven pi over 2. All right, that means I'm going 7/2 of pi. So in my mind, this is really what I'm thinking. 7 1/2 pies. That's 1 1/2, 2 1/2, 3 1/2, 4 1/2, 5 1/2, 6 1/2, 7 1/2. So now you're like, well, where do I go to the x-axis? Do I say this is my reference angle? Or do I say that's my reference angle? Guess what? This is the special case. This is something we haven't talked about yet. This is a quadrantal angle. Quadrantal means when the angle lands on one of the axes. Since the same distance here is 90 and the same distance here is 90, we say there is no reference angle because it's one of the special angles. So basically you have 4 special ones. Anytime your point lies right on one of the axes, it has no reference angle. And let's just move him down here. Cosine of 8/5 pi. All right, so it's 8/5 of pi. So 8/5, or 5/5, if you want to look at it this way, 8/5 is 5/5 plus 3/5 pi. So I went a full pi, 5/5, and I went 3/5 more, and we know 3/5 is more than 1/2, so I'm somewhere in here, and so I'm charged with finding how far is that angle right there. So that was to 2 pi is its closest x-axis. Whoops, don't want to do that. So I take 2 pi, take away 8/5 pi. All right, so let's put this in terms of fifths. That's going to be 2 in terms of fifths is 10/5. 10 minus 8, so that reference angle is 2/5 pi. Or you could see it right here, the shortcut, da-da-da-da-da-da, 3/5 plus 2/5 get you a full fifth. Did you see that? Yay! 2/5 plus 3/5 get you 5/5. 1/3 plus 3/3 get you 4/3. Yay! See all the shortcuts. All right, so sometimes they give us hints about the angle, and then we have to find the angle. Okay, in this case, let me edit that. We don't have to find the angle, because in this case, we're finding the cosine of the angle. Right, little typo there. But anyway, what the heck am I talking about? So they love to have you play games with the unit circle and give you clues about it and ask you different things. Can you find the cosine of this angle? Can you find the sine? Can you find this angle? What quadrant is this angle in? So we're starting to play those games right now. I advise you to always draw the picture. So an angle has a reference angle that has a sine value of -3/5. Okay, that just tells us something about the y value. If the angle falls in the third quadrant, all right, notice I didn't cross that off yet because I haven't used it. I'm going to draw my bullseye. You're going to be drawing these bullseyes all chapter 5. The angle falls in the third quadrant, so I know that my reference triangle, which contains my angle here, my reference angle, I know the sine, or the y value, is -3/5. Find the cosine of the angle. So they want me to find the x value right here. Well, there's ways using the clue, and there's ways using Pythagorean's theorem. All right? X squared plus y squared equals 1. We know that that's the case because it's a unit circle, and all unit circles have a radius of 1. Now, look, they gave you the y value, -3/5. So x squared plus, well, my y value is -3/5. Do it. X squared plus 9/25 equals 1. X squared equals 1 minus 9/25 when I solve it. So x squared equals 16/25. When I take the square root of both sides, the square root of 16 is 4, the square root of 25 is 5, and my answer could be plus or minus. Remember, when you take the square root of something, you introduce the square root. You don't know whether they're talking about the positive or negative. But in this case, we only want one of those answers. That's right. The answer is -4/5, because we are in the third quadrant. And in the third quadrant, x had a negative direction. We went over x and down y. Both sine and cosine, the x value and the y value, are negative. So that's how you are going to use Pythagorean's theorem. This will always work. But there's a shorter way that you could have gotten -4/5. I'm going to use the clues of the problem. Well, here's my triangle. And they told me the sine of that angle was -3/5. Well, if you remember from 8th grade in geometry, sine is opposite over hypotenuse. So the opposite of this is -3. The hypotenuse is 5. That means that has to be 4 because it's a 3, 4, 5 triangle. And since I went in that direction, it's a -4. That's why that's a -3. Cosine is adjacent over hypotenuse, and that is the other way to get the cosine of that angle. Pick whichever way you like. See you tomorrow.